Okay. So on that same note, you guys still, a couple things. If you didn't take the quiz on Friday due to absences or whatever, we will do it tomorrow. So if you did not take the quiz, I did not want you to miss the new material, otherwise I would have had you take the quiz today. You will take it tomorrow in class, or if you want to stay during lunch to take it, you could do that. You can let me know tomorrow, okay? But one of those options. So where is my stuff? There it is. So what we're doing here is, well, what we've already done, by the way, is add or multiply and divide. Believe it or not, multiplying and dividing, which was 9.1, is easier than adding and subtracting, okay? Because we have to find common denominators when we add or subtract. So on top of having to know how to factor, we have to find a common denominator and then change our numerator in order to match everything up, okay? So that's the first thing we're going to talk about is least common denominator, or LCD, least common denominator. It's the least common multiple of all denominators, okay? It's really no different than when you're adding or subtracting fractions like 1/2 plus 3/4. These are just varsity level fractions, right? You're in varsity math at this point, so we don't have those easy fractions anymore, we have the harder ones. So let's look at this first example, A. I need to add these two fractions together, but the way it's written right now, I cannot. I need to figure out a common denominator for 4b and 10, okay? Now, not just any common denominator, the least common denominator, because there's truthfully a multitude of denominators that would work for both of these, but we want the smallest one. So just like kind of we always do, I'm going to go ahead and rewrite this. I'm setting it up. I'm going to have two fractions, but I'm going to change their denominators, okay? So let's look at the numbers first, 4 and 10. What is a number that both 4 and 10 go into? The smallest one. What I couldn't hear you.
2.
No, that's okay. That's a factor. Okay, this is different. You are absolutely right. They have a 2 in common, a common factor, but what we want is like a multiple. So 20. 20 is the answer. What number do both 4 and 10 go into? Okay, so like 40 is an example. 40 is a multiple of both of those numbers, but it's not the smallest. You might remember this, and you don't need to write this. I'm going to show this to you real quick. If you took the numbers 4 and 10 and listed out their multiples, 4 times 1, 4 times 2, 4 times 3, times 4, times 5, times 6, and so on. Multiples of 10. 10, 20, 30, and so on. What's the first number that we get to that they have in common? It's 20, okay? So this is a method of doing it if you're struggling, okay? It's just listing them out. So 4 times 1, 4 times 2, 4 times 3, and so on. 10 times 1, 10 times 2. And the first number you get to that they have in common is the least common multiple, okay? So we know there's going to be a 20 in our denominator. Now we have to look at the letters. There's one B here and no B here. We have to have everything represented. If there's a number in the denominator or a letter in the denominator, it has to be over here. And 4 and 10 are inside of those 20s, so we covered that. But if there's a B here, we have to have a B over here, okay? And we'll keep talking about that. But 20B is your least common denominator. So what you're doing here, guys, is you're changing, for example, in this first fraction, we're changing 4b to 20b. What did we multiply 4b by to get 20b? 5. So if you multiply a denominator by 5, you have to multiply the numerator by 5. You can do anything that you want to a fraction as long as you do it to both the bottom and the top. So like I said, to go from 4b to 20b, we multiplied by 5. We're allowed to do that as long as we do the same thing to the top. Okay? Now look at the second fraction. What are we multiplying 10 by to get 20b? 2b, right? I want to get 20b, so I'm going to multiply that by 2b. That's perfectly fine as long as you do the same thing to the top. So 4 times 2 is 8. and then alphabetical order on our letters, B, C squared. Okay, now that they are a common denominator, we can add the numerators together. So our denominator is going to be 20b, and then we add these together. The problem is they're unlike terms. This one has an a in it, this one has a bc squared. We actually cannot add them together, so they just hang out together. And that would be your final answer. Yeah. If all of those coefficients, 35, 8, and 20, could be simplified, we would do that. Like if they were all divisible by 5 or 2 or 4, we would. But since they're all not divisible, oops, we just leave it. Okay? Let's do another one like that. And then we'll get to one where there's factoring involved. So if you look at B, just like A, we have monomials in the denominator, meaning there's no pluses or minuses, okay? So we know that they're not alike, so we're going to have to change those denominators. So we have a 9y and a 6z. What's the first number that both 9 and 6 go into? Evan, come on. 18, right. Again, if you didn't know that right off the top of your head, you could do your multiples. 6 times 2 would be 12, and you can use your calculator and type these in. 6 times 4, 6 times 5, and so on. 9 would be 18 and 27, and so on, but you can see 18 is the first multiple that they have in common, okay? So we're going to use the 18. And if it's in a denominator over here, it has to be in a denominator over here. We've got a y and we have a z. We're going to keep both of them. Both of them have to be included. You can't leave anybody out. So that would be our common denominator. Really? Right now? If it's an emergency, yeah, Dylan, go. Tyson. Guys, I'm in the middle of notes. I've never had this. Yeah, if it's an emergency, go. I mean, I'm not going to tell you you can't go to the bathroom. All right, so what do I do to 9y to get 18yz? Times 2z, times 2z. So 2z times 9y would give me this. So I'm going to multiply my numerator by the same thing. 2 times 2 is 4, and we have an x, and we have a z. So we're done with the first fraction. Now we take the second fraction. We're going from 6z to 18yz. We would multiply by 3y, right? If you multiply 6z by 3y, you get 18yz. Same thing to the numerator. So I have 7 times 3 is 21. Y times y is y squared. Evan, put your phone away. Then I'm going to put them together. So under a common denominator, now that they are the same, I'm able to subtract my numerators. Well, again, these are different terms. I can't combine when the letters and or the exponents are different. So it just becomes 4xz minus 21y squared. Take one last look at 42118. Are any of those simplifiable? And the answer is no. There's not a number that goes into all three numbers. Is there a letter that they all have in common? No. So we're just going to leave it just like that. Okay? I actually think those are harder than these. If they were both, like if this was 4xz and this is 21xz, I could actually subtract the numbers if they were the same exact letters. But since they're not, it's like if I said to you, add these two together, you'd be like, well, you can't. They're different letters. But if it was like 2x plus 3x, you'd go, oh, that's 5x. Okay, so these are different variables. So I actually think these are a little harder than this type. Okay, let me show you what I mean. Now, what you should notice on this last one, and we're going to do some homework problems together, and this last one is we have a polynomial, right? There's pluses and minuses. So going forward, if you can factor the denominator, you're going to. And we can factor this. This is a chart problem. I'm hoping you guys are getting to the point where you don't have to write the chart anymore. You're still welcome to, but I do not require you to do it. So I'm just asking myself, what two numbers multiply to get negative 15, add to get 2? We know the numbers are 5 and 3. Which one's going to be negative? Which one, guys? Not 5. It's got to be the 3. You want a positive 2. Please don't guess on those if you're taking a test or doing your homework. Use your calculator. You're allowed to use it. So pick up your calculator and type in negative 5 plus 3. Did I get a positive 2 when I did that? No. 5 plus negative 3. Do I get a positive 2 when I do that? Sure do. And it works in both columns. Yep. Can I what? Zoom in? Yeah. So we have plus 5 minus 3. So we had to factor that denominator. Can I factor this denominator? I can factor by taking a 5 out. GCF. Now, same exact thing we were just talking about. What is the common denominator? So remember what I said. If it's represented in the fractions over here, it has to be represented over here. You can't leave anything out. For example, one of our denominators has a 5 in it, so that has to be in our common denominator, okay? So 5 is going to be one of my numbers over here. Do you see how they both have an x minus 3? We'll take that. They each have an x minus 3, so they have that in common. And then we have an x plus 5. That has to be over here. Told you these were harder, guys. Told you these. That's why we're going to work on this exact type of stuff all week. All week we're going to work on these. Okay, now say it again, sorry. Yep, on Friday. So, like we just said before, look at this fraction, its denominator, and look what we changed it to. This became this. What is different from my left hand to my right hand? Just the 5, that's it, right? So what we did is we multiplied this denominator by 5 to get that denominator. We're going to do the same thing to the top. And here would be the distributive property. That's why I use those parentheses. Because I'm multiplying 5 by a whole binomial in the numerator. Yep. Okay, it wasn't there originally. I said, so pretend that's not there. I said, so here's my original denominator. This is what we're changing it to, right? That's our common denominator. So what's different from this finger to this finger? This one has a 5 in front. Yeah, yes. Anything that's in either denominator, Mariana, has to be in our common denominator. So since there was a 5 here, even though there wasn't there, it has to be represented over here, okay? These take a little practice, so it is very normal. I mean, you have people that get A's on stuff asking questions, okay? A's on everything. These are tricky. You cannot sleep on these, okay? You have to practice these with me. So keep asking questions like that, okay? But that's where that came from. So I'm going to do it again with this one here in a second, so stay with me. But I multiplied this one by 5 to get this, so I had to multiply the numerator by 5, okay? Now look at this set. Look, Mariana. So I'm looking at this here. This is my original fractions denominator, and we decided it's got to look like this. What does this one have that this one doesn't? Do you see? The x plus 5. So I'm multiplying the denominator by x plus 5 to get that. Whatever I do to my denominator, I have to do to my numerator. Okay? Now, 1,000th thing I'm going to tell you that's also tricky is there's a minus there. That means this is a negative 7. you're doing negative 7 times x and negative 7 times 5. How easy would that be to miss that? So I'm going to actually change this right here, guys. I'm going to change this. What? That's exactly right, JT. Because so this is basically what I'm doing. I'm going to change this to a plus and just give the negative to that 7, right? So this will become a plus, and then whatever I get here in my numerator. Negative 7 times x is negative 7x, and negative 7 times 5 is negative 35. Okay. Now, let's put it all together in one fraction. We have our common denominator of 5, x minus 3, x plus 5. The order of that doesn't matter, okay? It's all multiplied together. Are there any like terms in our numerator that we can combine? Robbie, remember what we were talking a second ago? You can only add if they have the same letters. Like 10x plus negative 7x, we can put those together. Yeah, so that's just going to be, 3x, sorry. That's a 3. And we can do 5 minus 35, which is negative 30. And that is your final answer. So you don't do these problems and end up with like a 7, ever. You're usually going to have some kind of funky looking fraction, okay? Now, let's do a bunch of homework problems together, okay? Page 129, one of the pages you just ripped out. We are going to practice these all week. Lots and lots and lots and lots and lots of encounters with these problems, okay? Yep.
How come instead of doing it by 2y, you did it by 2z? I don't understand.
Because this one already had a y. What is it? What is this denominator missing? That's in the. This right here became this. Okay.
Okay.
So we have the 9. What else do we have to do times 2? Right. 9 times 2 would give me 18. It already had a y in it. What didn't we have was the z. So that's why I multiplied that guy by 2z.
Okay.
And then this one was missing.
That by what that one was.
Yeah, it's whatever. And I'm going to do some more right now. Guys, it is very normal to be confused about these today. It's very, very normal. So don't give up, okay? We're going to practice a lot. But you guys need to stay off your phones, be participating, asking good questions like you are, okay? All right, to add two fractions together, we need a common denominator. These are not common denominators. We have to make a common denominator. What would our common denominator be? XY. If it's represented in the green, it's going to have to be in my purple, okay? If somebody has an X, that's got to go in our common denominator. If someone has a Y, that's got to go in, because everything that you see here has to be in our answer, okay? So then you decide from this denominator to this denominator, what am I missing? So in green, I'm missing a Y, right? I want it to look like that. So how do I make an X into an XY? I multiply the X by Y. I do the same thing to the numerator. That gives me 3y. 5 over y, I would multiply this denominator by x, because I want it to be xy. If I do something to a denominator, I do it to a numerator. Look right here, guys. One thing I've seen students do is they'll simplify it right here. They'll cancel the y's and cancel the x's. Well, guess what you'll have? The original problem again. So don't do that. Common denominator is now xy. We're allowed to add the numerators because the denominators are now the same, right? Same denominator. That's what the denominator is. And when I add 3y plus 5x, I get 3y plus 5x. That cannot be simplified. Okay, let's go a little bit harder now. Start with your numbers. We have 8 and we have 4. What is a common multiple of 8 and 4? Not a factor, not a number that goes into it, but what is a multiple of both 4 and 8? The smallest one, 8. 8 is the smallest. Are there others? Of course, there's a ton of common multiples, but we are going to take the smallest one, which is 8. Okay? Now let's look at the letters. Here's the trick. Here's the trick with the letters. Oh, they're the same, aren't they? Look, there's 2 P's, 1 R. That's exactly what we would keep over here. What changed in the first fraction? What changed from purple to green where my fingers are? Nothing. That means we don't have to do anything to the numerator. So 3 just goes right over. We didn't change the denominator, we don't change the numerator. What about the second denominator? What changed? Yep. Can we add 3 and 10 together? Yeah. If you could simplify 13/8, we would. Like if it was 14 over 8, you could divide them both by 2. But we can't, so that's good. Okay. 2c minus 7 over 3. How do we make a 4? Like, what's 4's denominator? If you don't see a denominator, it's 1. We just don't write it normally. So what would a common denominator be here? Just 3. We didn't change the first fraction's denominator, so we don't change the first fraction's numerator. Second fraction, we're going from 1 to 3. How did we do that? Times 3 times 3, we get 12. So we have a common denominator of 3. And combine any like terms. We have 2c minus 7 plus 12. We can combine these two. So I would have 2c, and then negative 7 plus 12 is 5. And of course, you could put that in your calculator. And 2, 5, and 3 are not divisible by anything. What would our common denominator be? Yeah, this is scary. Okay. Common denominator, m squared and p, right? They both have a p. We're going to keep that. This guy has an m squared, but this guy doesn't. We're going to keep that. They have to have, everything has to be represented. That takes practice learning that. Again, our first fraction's denominator doesn't change, so our first fraction's numerator doesn't change. Our second fraction's denominator went from p to m squared p, so that was multiplied by m squared. And you can't actually combine a 2 with a 5m squared. I'm just going to put it in a more friendly order. It's addition, so it's not wrong if you wrote it with the 2 going first. Just know that. It would not be wrong. And listen, guys, you cannot simplify those m squareds. The reason is because of this plus 2. If that was your final answer just like that, you could absolutely cancel the m squareds if there was no pluses or minuses. But because of the 2, you cannot. You want me to keep going? I'll let you guys do more on your own tomorrow when you're experts. They each have a 5, right? 5. Keep that. One of them has a y to the first, and one of them has a y to the second. How many y's do you think we're going to keep? 2. Good. So you take the bigger number of whatever you have. We had 1 5, we kept 1 5. We have 2 2s or 1 2, we'll keep the bigger number. 1 z or no z's. No z's. We're going to just keep 1. Okay? Yeah. You mean this order here? Like, could you write y squared 5z? Is that what you're asking me? Z can't have a power of 2. Yeah, only the y should have a power of 2. But if you're asking me if the order in this denominator could change, like could you put the z first or something, you could. Technically, it's not wrong, but it's best to put your number first and then your letters in alphabetical order. Okay, that's what I'm doing here. Okay, in our first fractions denominator, we multiplied by z. So we're going to do the same thing to our numerator. What are we missing in our second denominator? A y. So there's 2. So think of it this way. There's 2 y's on the right, only 1 y here. We need to multiply by another y. Now I didn't have to do a distributive property here. It's just 2 times y is 2y. So this minus is not as tricky as some of the other times we've seen. So 12z minus 2y, right? Different letters we can't actually subtract and make a 10 or something. But we can just show that they're subtracted over our common denominator. And if 12 and 2 and 5 were all divisible by a number, we would simplify it. I'm hoping this is getting a little bit easier for you guys. Hoping. So we're going to keep a 4, right? They both have a 4, so we'll have that in our common. One guy has a G and the other one doesn't, so we have to include it. They both have to have that. And we have 1 H and 2 H's. How many are we going to keep? The bigger number, 2. Always take the bigger number because everything has to be represented. We're covering 1 H when we have 2 of them, right? There's 1 inside of there. But if we only put a 1 over here, we're missing this other H. Multiply this denominator by H. Right, to get h squared, we need to multiply by h. That's 7h. And the second one's missing the g. Put it all together. And because of that plus, remember, you can't just cancel stuff. Say it again. Did you answer your own question? Okay. Okay, finally we get to some factoring. I know you were missing the factoring. Right, Errol? So what's different? Guys, look at 1 through 6 compared to number 7 is we have binomials in our denominator, which means you might be able to factor. W minus 3 isn't factorable, but you should recognize this guy as the difference of squares. W plus 3, W minus 3. Okay, same idea with the common denominators. We have a W minus 3 on one and a W minus 3 on one, so we're going to keep a W minus 3. This one has a W plus 3, but this one doesn't. You have to keep that too. So remember, if it's in one or both of those denominators, it goes in our common denominator. And we do the same exact idea. In the fraction on the left compared to the fraction on the right, what is missing? We are missing a W plus 3, right? We are missing that. Distribute. What are we missing here? What? Nothing. W plus 3, W minus 3. W minus 3, W plus 3. They're the same exact thing. So if you're not changing your denominator, you're not changing your numerator. Put it all together. You can combine those two. 9 minus 2 is 7. And it doesn't matter if you put the plus 3 first or the minus 3 first. Doesn't matter at all. Okay, number 11, our last one. You should notice that there is a chart problem in one of the denominators. I told you chapter 9 is all factoring. So, guys, always look at your denominators and decide if anything needs to be factored. That's your first step, okay? In 1 through 6, we didn't have any factoring. We didn't have factoring until we got to 7 and now 11. We have to recognize that. That is what two numbers multiply to get negative 3, add to get negative 2. 3 is a prime number. There's only two numbers you can multiply to get 3. Now you play with the signs. 1 negative or 3 negative? JT, does it matter which one I make negative? Yeah. You can't. Can I make the 1 negative? No. I would get a positive 2. I want to make the 3 negative. Remember, guys, there's only so many things that you could do in your calculator with those two numbers. If you did negative 1 plus 3, you get a positive 2. We don't want positive 2. If I make them both negative, I get a negative 4. I certainly don't want that. If I make the 3 negative, that's how I get a negative 2. So it matters which one you give the negative to. Over here it doesn't. 1 can be negative or 3 to get a negative 3. That's why we make our decision in this column, not that column. This one just tags along. Okay? So doing nothing to that one. Okay? Common denominator. Yep. Say it again. Great question. You do not factor the numerator. Okay? Great question. I didn't even mention it. So that second numerator is factorable. You don't have to factor the numerators. Because remember, you're going to be combining like terms. So if it's in factored form, you can't add. You wouldn't be able to. I'll show you what I mean. But let's talk about the denominator. We have an n minus 3 in both of them. We'll keep that. They each will have an n minus 3. And one of them has an n plus 1. So that also has to be there. Okay? This first fraction is missing the n plus 1. The second fraction is not missing anything. Oh, this one's got something tricky in it. So I'm going to show you guys something in pencil, so don't write this. Don't write it. I just want to answer Mandy's question real quick. If you had factored this, you would have had that, right? You can't really see that. Okay? And then how would you have added together anything in that form? Okay? You might have had 2n. You could have written that here, but now we're going to combine like terms, and you couldn't add. How would you add anything in here the way it's written there? So you don't factor the numerator until the end, if possible. That's what I'm about to get to. That's a little tricky. Okay, we know our common denominator is n minus 3, n plus 1, right? Any order, you can flip those if you want. Combine like terms. I see these two are alike. Yep. When I multiplied my numerator by n plus 1. Oops. N times n is n squared, and n times 1 is 1n, or n. You see it, Sarah? Okay. It's distributive property. It's a monomial times a binomial. Okay, so then we have n squared plus 3n plus 2. Now, guess what? That numerator is a chart problem. You can factor that numerator and then simplify. This is the type of problem you just had in your last quiz, where you factored the numerator, you factored the denominator, and you canceled anything. So sometimes on these polynomial ones, you can do another step at the end. The two numbers are 2 and 3. 2 is prime. There's only two numbers that add to get, multiply to get 2. They also happen to add to get 3. And the n plus 1s cancel. Your final answer, finally, so like I said, it is going to take practice all week, guys, for us to get to the point where we know, oh, can I do this or am I done? Like, knowing when you're done on these problems is half the battle. Guys, Albert I.O. is due tonight, and there is a new one for you. Easy homework points.